Hi to all, welcome to learn engineering electromagnetics, vectors, algebra. The vectors algebra. What is addition, scaling, and subtraction, multiplication? Or four methods we can be considered as vectors algebra. Scaling of a vector. What is first? We go for scaling. What is scaling of vector? What is scaling of vector? The scaling is nothing but multiplication by a scalar. The scaling of a vector is known as multiplication by a scalar to a vector. This is nothing but multiplication by a scalar to a vector. Such a multiplication is changes the magnitude, that is length of the vector. Magnitude అంటే చెప్పాను కదా, స్కేలింగ్లో లెంత్ మాత్రమే చేంజ్ అవుతుంది బట్ నాట్ డైరెక్షన్. అంటే వెక్టార్ని స్కేలార్తో మల్టిప్లై చేస్తే, if you multiply with scalar, vector is multiplied with scalar, then only magnitude will changes but not direction. When the scalar is positive, it is okay. Now assume that a vector is OA. Assume that it is a vector. Now if we are multiplying an alpha is the scalar. Assume that in దీన్ని మనం మల్టిప్లై చేసామనుకోండి ఈ వెక్టార్తో, if it is multiplied with a vector alpha a, it becomes okay. If alpha is greater than 1, it is like that. That is the alpha a may be increases, the magnitude of alpha will be increases. If alpha is greater than 1, the magnitude of vector increases but direction remains same. That is scaling of vector. If alpha is minus 1, then magnitude remains same but direction of the vector reverses. If alpha equal to plus 1, it is all the magnitude will increases. If alpha is less than 1, that is less than 1, if alpha is less than 1 or minus 1, then magnitude remains same but direction will be reverses. Alpha a, it is, that is alpha is equal to minus 1. Okay, as the addition, that is the scaling of vector. Now we go for addition of vector. Okay, before going for addition of vectors, so what is scaling? The multiplication by a scalar to a vector, it is known as scaling. If you multiply with the scalar to any vector, the magnitude will be changes, the direction will be changes. When the scalar is positive, only magnitude will changes. Magnitude and the direction, that is the length, not the direction, length of the vector will be changes. If it is in minus 1, the direction will be changes. That is the multiplying with scalar is nothing but scaling of a vector. Okay, now we go for addition of vectors. Second one, vectors algebra, that is addition of vectors. Addition of vectors. Consider two coplanar vectors. The vectors which are lie in same plane, that is coplanar vectors. Coplanar vectors are considered two coplanar vectors. The vectors which are in the same plane, that is known as coplanar vectors. That is that two a, it is assume that it is origin and two vectors a and b. A and b are the coplanar vectors. These are the same plane. Okay, the resultant, the c is the sum of vectors. Addition means c equal to a plus b. If you how to sum this? By taking the resultant a and b, by drawing a line like this. Parallelogram theory, we are using parallelogram rule for addition of vectors. This is the c, addition of vector c. Resultant will be c equal to a plus b. Okay, let us find how to find the sum of two vectors. The procedure is to move one of the two vectors parallel to itself. Parallel to itself, moving the one of the two vectors. That means it has to move parallel to itself. The procedure to move one of the two vectors parallel to itself are the top of the other vector. Thus move a parallel to itself, then parallel to itself means that is b. This is the OA. It is the a vector. Then a plus b is the c. C is the vector. This is the resultant of sum. Resultant. Now we go for subtraction of vectors. That is vectors algebra. What is subtraction? Subtraction of vectors. subtraction of vectors. The subtraction of vectors can be done from the addition only. Addition. What is C equal to A plus B is the addition. Consider two vectors A and B. The resultant vector is C. But subtraction will be done by taking negative of B. A plus minus B. That is C. The reverse of the sign of B, the reverse direction of multiplying with minus 1, then we are getting subtraction. Consider two vectors. Let us see two vectors, that is A, that is B. Assume that two vectors are like this. Previously what we assumed, that is A, B. Okay. Now we are doing negative of this. B is the negative. This is minus B. Negative of xx, this is the origin. Assume that two vectors previously ela anukunnamo A, B. Similarly we taken negative of that. The resultant of negative is C. This is a C equal to A minus B. The same principle, parallelogram rule we are using. Identical vectors. Next is subtraction of vectors is over. Now we go for identical vectors. Two vectors are said to be identical if the difference is 0. The difference is 0, then A minus B is 0, A equal to B if both are equal, C equal to 0. That is A minus B equal to 0. A minus B equal to 0 means identical vectors. Those are identical vectors. If the vectors said to be identical, if there is a difference, the difference between two vectors are 0, then the vectors are said to be identical vectors or equal vectors. Identical vectors also known as equal vectors. Now we go for vector multiplication. How to do vector multiplication? How to do vector multiplication? Similarly, addition, subtraction we discussed previously. Now we go for multiplication by a scalar to a vector or between two vectors. How to multiply? Two vectors A and B are the two types of products that exist between that. One is scalar product. Scalar product. It is also known as dot product. Dot product it is known as. Scalar product. The two types of, consider two vectors A and B. Two types of products exist depending upon the resultant of multiplication. The two types of products are scalar product, or that is also known as dot product. Second one is vector product. Vector product or cross product. It is also known as cross product. Let us discuss the characteristics of these two products. What is scalar product? What is dot product? Two vectors multiplication can be done in two ways. One is dot product, that is scalar product. Now we go for scalar product or dot product. How to do dot product? It is very important before starting electromagnetics. Hence we are discussing all this vectors algebra. Previously vector analysis is over. Now vector multiplication. Multiplication is done in scalar and vector. Two methods we are using, scalar product or dot product. Simply we can say dot product is between A dot B, two vectors A dot B, like this we can represent. What is dot product? Let us go. The scalar product or dot product of two vectors can be represented, denoted as, can be represented or denoted. How to denote dot product? A dot B. Consider two vectors. Two vectors may be considered as A and B. Dot product will be represented like this, A dot B. Yeah, it is the dot product. It is defined as product of magnitude of A and product of magnitude of B and the cosine of the smaller angle between them. That is the smaller angle between them. The A dot B can be represented as, how to do dot product is magnitude of A we have to consider first. Consider two vectors A and B. Consider two vectors A, it is a B. Okay, the angle is theta. The dot product, two vectors scalar product, it is dot product. A magnitude of A into magnitude of B into cos of angle between them, theta AB. That is the dot product. A magnitude, B vectors magnitude, and cosine of the angle between them. That is, it is also can be defined as product of magnitudes of B and projection of A to B. Projection of A onto the B. A onto the B. Projection. It is the projection. If you project, this is O A. If you project like this, then up to this, it is the projection magnitude of A, magnitude of B into cos theta of AB. The result of such dot product is scalar. Scalar vastundannamata. Dot product of two vectors is a scalar, that we have to remember. The dot product of two vectors, it is also called a scalar product because the output, the resultant or the result of such product is scalar product. Hence it is known as scalar product. Okay, what are the properties of dot product? Properties of dot product. After that we go for vector product, that is cross product. Now we go for properties. Properties of dot product. The various properties of dot product are, what is the, it obeys the two parallels are A dot B is a, for parallel vectors, A dot B, two vectors are in parallel, that is theta is 0, then what becomes A dot B equal to A vector magnitude, B vector magnitude, and cos of 0. Cos angle of 0 degrees is 1, therefore simply directly A is multiplied with the product only, magnitude only. If the two vectors are parallel to each other, then theta equal to 0, cos theta becomes 1. Hence A dot B equal to magnitude of two vectors we have to multiply. If the two vectors are perpendicular to each other, that is the first one is parallel. If the two vectors are parallel to each other, then A dot B equal to 0. If the two vectors are perpendicular to each other, A dot B becomes cos 90 is perpendicular, means 90 degrees it is. A dot B is magnitude of A, magnitude of B, cos 90 degrees becomes 0. A dot B is 0. The dot product of obeys the commutative law. Commutative law it obeys. That is A dot B equal to B dot A. It obeys the commutative law. The dot product obeys distributive law also. Okay. Consider two unit vectors. Two unit vectors AX and AY, AZ. These are the three unit vectors. What is the dot product of two unit vectors? Let us see. What is the properties? If you consider X, Y, Z axis, X axis and Y axis and Z axis, AX is the unit vector, AY is the unit vector, AZ is the unit vector. Okay, the dot product of AX dot AY, what will happen? AX dot AY. AX ki AY ki angle anta untundi? Right angle to each other. AX and X axis, Y axis and Z axis all are right angle to each other. AX dot AY equal to 0 because cos 90 is 0. A magnitude of AX, magnitude of AY into cos of XY, cos theta XY. Thus AX magnitude is 1 and Y axis magnitude is 1 and cos of XY is 0. Cos 0 is cos theta. What is the angle between X axis and Y axis? 90 degrees, perpendicular to each other. Okay, cos 90 degrees, that becomes 0. Similarly, AY dot AX equal to 0. That means all we can write the dot product AX dot AY equal to 0, that equal to AY dot AX equal to AX dot AZ equal to 0. Any unit vector dotted with itself is a unity. AX dot AX చేసామనుకోండి. Another property is unit vector multiplied with the same vectors. AX dot AX అంటే AX అంటే ఇలా ఉంది, ఒక యూనిట్ వెక్టర్ AX. దాని ప్యారలల్గా ఇంకో యూనిట్ వెక్టర్ అజ్యూమ్ చేసుకుంటే AX dot AX ఏమవుతుంది? magnitude of AX, magnitude of AX multiplication and cos of angle, cos 0 degrees it is. అంటే ఏమవుతుంది? 1 into 1 into 1, that is 1 only. AX dot AX equal to 1, AY dot AY equal to 1. Similarly, ay dot ay equal to 1, az dot az equal to 1. That we have to remember. These are very important. Ax dot ax equal to 1, ay dot ax equal to 0. Okay, these properties are very important coming to electromagnetics. Hence we are discussing that product dot product. Whereas cross product is sign of the angle we have to apply. Let us see the cross product. Now we go for cross product. Multiplication vector, vectors multiplication or cross product. Cross product of two vectors a and b is denoted by a cross b. Two vectors cross product ఎలా రిప్రజెంట్ చేస్తామంటే a cross b, it is a cross mark. A cross b we are representing. A cross b is one of the formula we have to remember, that is magnitude of a, magnitude of b and sine of angle between them, sine theta of ab, and unit vector is an. It is a direction of normal direction, unit vector perpendicular to a plane of a and b, it is unit vector, that we have to remember. Okay, similar to that, a cross b equal to b cross a, that is a dot b equal to b dot a previously, but ikkada a cross b, a vector and cross product of b vector is not equal to b cross a, that is the cross product is not applicable for commutative law. Okay, next b cross a you can write as b cross a equal to minus of a cross b, that is also that. Reversing order of the vectors reverses the direction, that is b cross a equal to minus of negative of a cross b, that is anti-commutative in nature. The commutative law is not applicable, but anti-commutative law will be applicable for cross product. Now we go for cross product of unit vectors. Cross product of unit vectors. Cross product of unit vectors, we dot product ఎలా చేసామో అలాగే ఇక్కడ చూద్దాం. ax cross ax is the unit vector, ay that equal to magnitude of ax, magnitude of ay and sine of angle, sine 90 degrees, and unit vector is an, the normal to xy plane. In this case an equal to az, because xy and perpendicular plane is 90 degrees, that is z axis. Okay, an equal to az. Why we assumed that perpendicular angle, an is perpendicular angle. Okay, perpendicular angle, an equal to az, and ax equal to ay, that equal to sine 90 degrees equal to 1. Hence ax cross ay equal to az will come, because sine 90 degrees into an వచ్చింది ఇక్కడ, into an we have to consider, into an unit vector that is normal to xy plane. xy plane నార్మల్గా ఏది ఉంటుంది, z ప్లేన్ ఉంటుంది, అంటే ax cross ay ఈక్వల్ టు az వస్తుంది. ax cross ay resultant is az. Similarly ay cross az is ax, ay cross az equal to ax. Similarly az cross ax equal to ay, other plane will come, that is if you multiply with ay cross ax, minus az will come. Previously ax cross ay is az. If you alter this, if the order of the unit vectors are reversed, then ay cross ax is ay cross, if the order of the vectors are reversed, then ay cross ax equal to minus az, negative of that. How can we represent ay, magnitude of ay into magnitude of ax into sine 90 degrees, but direction will be opposite of that. Previously z axis positive, it is negative axis, hence minus az will come. Okay, that product, the dot product can be expressed in determinant form also, That is also important. A cross B equal to, how to represent a dot product. If A equal to, assume that A equal to a vector, a point can be represented as Ax comma Ay comma Az are 3, and B equal to Bx comma By and Bz. Then A cross B equal to, how to represent A cross B equal to, how to represent A cross B in determinant form. We can represent Ax, Ay, Az, and it is Ax, it is Ay, Az, it is Az, and Bx, By, Bz. Like that we can represent a matrix form in determinant form. The resultant can be expressed in determinant form. This is about vectors algebra, not vectors analysis. It is one of the part of vector analysis. It is a vectors algebra: scaling, addition, subtraction, and multiplication. These 3 or 4 vectors algebra is very important for electromagnetics. Hence, we have to know accurately, and we have to apply in different coordinate systems this vectors algebra. Thank you.